Hi, so in this video we're going to take a look at combining symmetry elements. And we're going to keep it pretty simple, looking at combinations of, let's say, a two-fold rotational axis and a mirror plane. So how many ways can we combine two-fold rotation axes and mirror planes? Well, we'll show a couple of the possibilities. So if we have a two-fold rotational axis here, that's usually shown by this symbol, an ellipse with sharp points on it. We can imagine a mirror plane that is drawn perpendicular to that symmetry axis. So we'll just draw M for a mirror plane. And the way we would notate that is we would write 2 backslash M, or 2 over M. So that would indicate a two-fold rotational axis with a mirror plane perpendicular to it. Maybe an easier way to show this is we can show this plane, and then we'll have the two-fold rotational axis, and it's being cut by that mirror plane. So this is the same thing, I'm just redrawing it, two-fold axis and a mirror plane. You can also draw the mirror planes being parallel to the axis instead of perpendicular. So imagine a two-fold axis here. Then there's a mirror plane that cuts it there, and another mirror plane that cuts it in this direction. We could have two mirror planes, and instead of a backslash, we'll just draw the ends next to each other. So this is a two-fold axis with a mirror plane parallel to it and another one parallel to it. We'd call that a 2mm. And that's the reason why I'm using this very nice diagram by Bloss here, because that is my feeble attempt there. But here's a very nice diagram that illustrates it almost perfectly. So we have the case of a 2mm here. Here's the two-fold rotational axis. One mirror plane cuts it right to left, and another mirror plane over here cuts it front to back. And those two mirror planes together with the two-fold axis give us the symbol 2mm. And then something I wouldn't even attempt to draw is the sample of a 4mm. So we can have two mirror planes that would cut a four-fold rotational axis here, and then those mirror planes would act on one another to give additional symmetry elements. The four-fold axis is going to act on the mirror planes themselves to give us two additional mirror planes. So you can see a mirror plane here in the diagonal, and then another one in the diagonal here, and then there's one front to back and the other one left to right. And those were as a result of having this four-fold rotational axis act on those other two, those original two mirror planes. We have to have them. Those mirror planes have to be there, otherwise we would not have this four-fold rotational symmetry. And combine those, then we get the symbol of 4mm. We'll take a look at some other combinations, not all of them, but ultimately what we'll find are that there are 32 possible combinations of combining the various elements of I, and then two-fold, four-fold, six-fold, three-fold rotational axes, bar 2, bar 3, etc. There are only so many ways that we can combine all these things with one another and with mirror planes, and the total combination comes out to 32, and each of those defines a point.